So CI CD has been gaining a lot of traction online these days, be it for marketing buzz or maybe the newcomers in DevOps. Those guys are actually enticed by what CI CD is. Adding that Docker is in the ecosystem. So doing CI CD today is very, very easy as compared to what it was like 5 or 6 years back when there were no containers. And Jenkins used to rule the market, where it used to provide you a task runner and you would define your jobs sequentially or parallelly. But it did lack some of the new features that the newest tools are providing. And that one of the new tools that we're using today is GitLab CI CD. I've been using GitLab CI CD for around 2 years now, and it has matured a lot. It provides you like very flexible options to tune and configure your pipelines in any way that you want. And many companies are also using that in production. So let's start with what CI CD is in the first. I mean, I'm pretty sure that everybody here might be knowing CI CD in bits and pieces. But just for the sake of the clarity, I mean, what it actually means. So CI CD is actually a culture, set of principles, and collection of best practices that enable application developer teams to deliver code changes more frequently and reliably. And so developing and releasing software becomes challenge as team scales. So if there are a team of 2 or 3 people, you wouldn't actually mind doing everything directly. You build the code, you test the code yourself, and deploy it to the production. But when your team increases, there are a lot of interaction points, and the probability of error increases. So that's where CI/CD pipeline comes in. So if you have to remember one motto for scale, at scale, speed and consistency matters. That's the only thing that can make or break your product. So if we talk about Uber, like Uber recently published some blogs where they published that they are having around 6,000 microservices internally, and the team actually has more than 500 active developers who are contributing to these repositories. Now imagine such a system where you have to manually build test or code, or somebody is assigned to do that. The whole pipeline will suffer, and Uber won't be able to publish changes as they're doing right now. So definitely CI/CD is the only thing that is helping companies at scale to move faster and more reliably. So now CI/CD consists of continuous integration, continuous delivery, and continuous deployment. These are not so very clear at the start, but as we'll proceed through this presentation, we'll get to know what each phase means and how we can use each phase in our own product or companies. So moving ahead with, first of all, continuous integration. So this is a practice that encourages developers to integrate their code into main branch of the shared repository early and often. Instead of building out features in isolation and integrating them in the development cycle, so code is integrated with the shared repository by each developer multiple times through a day. So imagine you having a repository on GitHub, and you have set up a policy that any developer can come and push in the code. But you just need to ensure that the developer is following your best practices, code styling, and most importantly, the test cases are not failing. So as long as these 3 requirements are fulfilled, you shouldn't disallow anybody to check in your code. And that is what helps companies at scale. So if you have good, pretty much standards at repository level, you can make this whole process automated. So first of all, talking about integrating the code into main branch as quickly as possible. So it reduces the cognitive load of merging large changes, and thereby increases the probability of merge conflicts. So if you are able to integrate very small changes and there are some bugs, it will be very easy for you guys to fix that up quickly, instead of compiling a group of 10 or 20 commits together and then trying to figure out what went wrong. So it's a very good practice that you run continuous integration on each commit that you apply. Then comes about the cost of integration. So code styling, linting, documentation, and other static analysis can be applied at this level. So for example, you're using Python, and you have a pretty much good standards at how each variable should be declared or how your file should look like. You can run Pylint at this level. So this is the stage where you can do you can check all the measures. So just to ensure that the code that has been introduced fulfills the criteria. And similarly in the node, you can use ESLint or maybe for any other languages. Small conflicts and errors are actually easy to fix. That's why I'm repeating this point, because if you check that after 10 commits, the code styling was not properly followed, it becomes really tedious for the developer and the maintainer to go back and fix them and then come back. So if there's a system that can tell you at each commit level, like what went wrong, it will be very easy to fix. And then speed is the key. So if the CI times are increasing, developers will be really, developers will actually won't use this kind of system because that will prohibit them due to speed. So let's say you have set up a CI point in your repository and it's taking around 5 minutes for each commit. Definitely the turnaround time is so great that the developer loses focus and like concentrate on some other task. And eventually at the time when they need to integrate the code in the emergency, they will try to find other bypasses, and thereby your whole CI CD pipeline actually fails because somebody searched for a new path that would deploy the code much faster, but in an unreliable manner. So it's very important that the CI steps that we run at each commit level are really fast, so that we don't waste developers' time. So since CI checks are at very macro level and usually fast, they're suitable to apply for each commit. And this increases the confidence about the code quality early in the cycle. So, sorry. And most importantly, CI actually starts at your local level branches. So since CI is a practice of integrating a code as early as possible, it's very important that you guys follow best practices at your own local level. If we are using Git, there's a feature called pre-commit hooks. So pre-commit hooks execute a functionality each time you commit. And if you apply code linters and other kind of static analysis at a local level, it will actually increase the likelihood of catching a bug early in the cycle. Instead of relying on the remote CI CD system, you should first start applying CI on your local system, because that is the most fastest way to check and get confidence at a code level. And following the next point logically, unit test cases are the first class citizens of CI. So since unit test cases target components in isolation, they are usually very fast and robust enough to signal catastrophe early in the process. And this makes them very suitable for the CI. Then coming back to the integrating code, CI should be consistent enough to be a repeatable process, and that is very important. And integrating the same code multiple times in playback should always yield in the same result. So if your CI is introducing flakiness, or it is producing different kind of results whenever you apply the same cycle on each commit, that is not going to work. The whole point of CI is that your all the processes are in the consistent state. And if I apply same CI on same commit, it should yield the same result. If it failed, it should fail every time. That is very important. Now, coming to continuous delivery. So continuous delivery only happens after CI. It has to ensure that first CI is done, and then we add delivery to it. So continuous delivery starts where CI stops, and it focuses on automating software delivery process so that teams can easily and confidently deploy the code to production anytime. And so focusing on automating software delivery, so continuous delivery includes all the steps necessary to make your software deployable. This includes running comprehensive tests, quality assurance using tools, creation of builds, code signing, generating documentation, and deployment to pre-prod or user acceptance environments. So you can think of continuous delivery as everything except the deployment. You prepare deployment, but you don't actually deploy it to the production servers, and you leave it to human intervention step that will actually ensure when and where to deploy. So it's suitable for teams where continuous deployment is not something that they want. So for example, you're developing a website and you had done a marketing for some feature to come. And so what you would essentially do is that if the release date on Sunday, you would prepare a code on Saturday itself so that everything is ready, and technology team can be like freed away from deploying responsibility. Now it's a responsibility of the marketing team or some other team, and they can do it anytime they want. So continuous delivery will help you in that phase where you want to remove technology team from that kind of responsibility. And then It leans heavily on deployment pipelines to automate testing and deployment process. So success of continuous delivery depends on the level of automation of software testing and robustness of automatic quality checks. This is the latest stage where critical or breaking changes should be detected and communicated. And it's more important to reject okay seeding changes than to accept them. So if you have any doubt, like if this code is not performing well, or let's assume that it's throwing warnings, so this is the best time you should reject the code. And since industry is moving towards completely automated deployment scenarios, even the warnings should be considered very importantly. And if you have any doubt that this code might fail due to some warning or maybe some deprecated software being used, you should reject that thing from continuous delivery at that point in time. And coming on to the next point, continuous delivery is attractive because it automates the step between checking the code into the repository and deciding on whether to release well-tested functional builds to a production infrastructure or not. And there are many techniques available to deliver functionality and keep it in the dark state without letting your users know. So this includes flag-based activation. This includes environment-based triggering. So for example, you developed your whole product, you built it, and then you silently deployed it into production. Now the normal users cannot see this unless and until they have special authorizations from the team, and maybe there are some collaborators, and it's only until it's publicly released everybody able to see those products. The whole point that I'm repeating here is that continuous delivery allows you to prepare everything before the deployment. So then by ensuring that the code base is always in the deployable state, releasing software becomes an unremarkable event without complicated ritual. And teams can be confident that they can release whenever they need to without complex coordination or later stage testing. And finally comes for the continuous deployment. So continuous deployment actually follows after continuous delivery. And it's extension of continuous delivery actually. And it does everything continuous delivery does and takes a further step of automatically deploying the new release or version on the production. So in the previous step, we discussed that it's up to the marketing team or the product team when to release that software. Continuous deployment actually a step further. Now, for example, let's say Chrome, or maybe you have been using Firefox Developer Edition. So these are the software where continuous deployment is automatically applied. And if you might have seen that there are nightly builds that come out every day. So if you have subscribed to the channel, those guys push a nightly build of Chrome every day, so that you can check like what's new in the dev version. So these kind of software are actually without any hassle in between, and as soon as they pass all the requirements and the restrictions on the code base level, the product is shipped to the users directly. The only requirement for a build to be deployed is that the process, the checks and test setup guarantee crash-free experience. Now, since it's a completely automated system, it's imperative that you guys spend more time developing very strict test cases, because here you don't have any chance to like manually review this product. Once it's gone, it's gone. So the continuous deployment should have the strictest rules, as strict as possible before deploying the code, because since it's an automated system and there's no human gatekeeper required. So unlike continuous delivery, no manual trigger is required to deploy a new version to the production. And high confidence build system benefit a lot from this kind of functionality. Then like pushing out 5 new builds to production in a day may not be something that all the teams get comfortable with. And many techniques exist which assist team in selectively rolling out changes to users, such as canary deployments, flag-based deployments, A/B testing environments, and then the dark launches. So GitHub recently published a blog where they showcase a system which would allow teams to continue to deploy new versions of the software, but it would add a layer of reliability over that. So they explain it like this. So for example, you have a microservice running and there's a load balancer, and let's say someday a new developer pushes a new change that passed all your tests. Now this new system is deployed as quickly as possible at that point in time. But what happens is the previous instance is not thrown out. So whenever user requests some kind of service from that kind of application, it will still be served from the older application. And simultaneously, that request will be copied onto the newer version as well. And so the system is intelligent enough that it will try to match the response from 2 systems and then return to the user, which came early. So in this manner, even if the new service crashes, the users won't face any downtime because it will be served by the older application. And going further, if like after 1 week or 2 weeks, they find that the reliability scores are actually matching and the new service is responding much like the older service, then they can safely remove that thing. So these kind of techniques actually are required when you want to use continuous deployments. And so as continuous deployment is the last step in the chain of automated pipelines to production, it's imperative that the checks and tests are at this level are the strict tests. Anything less than 100% should be rejected at the outset. Like there should be no leeway. If the everything is 100%, then only you can move it to the production. And then finally, even after all the benefits, continuous deployment is in no sense one-size-fits-all kind of strategy. And teams should validate the requirement and only adopt continuous deployment if the development environment, approach sensitivity, and the test system allow seamless adoption. And if the systems in the place are not mature enough, adopting continuous deployment might prove to be a catastrophic decision for any team. And most teams go with continuous delivery and stop there. And there's no harm in that. So it totally depends on what are you building and how critical is that. And like there's no hard and fast rule that you should actually use continuous deployments. Now coming to the best practices. So the first point, as already discussed, the success of CI CD systems depends on the execution speed. If CI cycle takes huge amount of time for each commit, developers will find an alternative and faster bypasses to get the code integrated very quickly. And this involves pathways which skip tests in favor of optimistic updates. And this can cause havoc in the production. I don't think I even need to mention the consequences of integration untested code. So it's very important that CI CD is fast enough so that every developer in your team adopts that. Secondly, often ignored, but it's very crucial to protect your CI CD environment. It's one of the most sensitive piece of infrastructure to protect, as it contains access to your code base and highly other sensitive data. So since your CI CD pipeline is having access to your code and all the credentials, it's even more important to protect them from the production servers. Furthermore, it's one of the most used systems in the large and high frequency development teams. Any outages on the CI CD can cause tremendous loss of productivity and financial losses in the worst cases. Now, CI CD pipelines are as successful as the last person using them. And all of the effort in developing CI CD fails if it's not adopted by the team. So CI CD should be strictly only the way to deploy to the production. In fact, the rollbacks should be deployed by the same pipeline. And coming to the next point, ability to roll back a change shouldn't involve complex procedures. It should be as simple as possible to roll back a change. And it's always better to roll back changes at 3 AM rather than debugging them on the prod. And so like, it's very important that the platform you choose for CI CD should allow easy rollbacks. In terms of Git, if you want to undo any change, Git revert is the first thing that comes to your mind. So similarly, when you reverted any change, it should be like deployed by the same pipeline. And it will essentially roll back the change that you pushed. But today, the newer tools provide you even better functionality where you can just roll back the change by a single click. And if you can ensure that all the changes in your Git repository are coming via merge request, it's even easier to roll back a group of changes. So always keep in mind while developing CI/CD systems that the rollback option is very important. Now, you should run your fastest test early in the pipeline. The idea is to reject the build if it fails any test. And rejecting early saves a lot of time and makes turnaround time really small. And if you think about it, like, so for example, you have 6 tests in your test suite, and you know that one of the tests is like the fastest, and so you should run the test first. And if ever possible, you should run all the tests in parallel because it saves a lot of time. So depending on the infrastructure and where CI/CD built, doing parallelization will benefit you a lot and will keep your CI/CD times very small. So now this point is actually for both DevOps and developers. CI starts as a local development environment, and all basic CI tests should be first run on your local system, as it's very fast and saves time and conserves CI/CD in front of the platform for more critical later stage pipelines. So since whole company is dependent on a CI/CD pipeline, and if you feel that the changes you are doing can be tested on a local system, please do that. It saves the bandwidth. So let's say the other guy in your team is doing some very critical change, and he has to wait just because you didn't run those steps on your local system, and you know that it would fail. So it's very bad on their part. They have to wait for such a long time. Since there is a very limited capacity for CI/CD things, we should always do some consideration that if there's something that can be detected at our own environment, we should do it instead of like wasting the expensive resources that the CI/CD systems are running on. Now, tests should run in ephemeral environment. So in order to provide consistent results for CI/CD pipeline, it's very important that the tests run in a fresh state every time. This is because like if you're reusing same environment repeatedly, the side effects from a previous run might impact your test in future, and this introduces flakiness. And as we have discussed, flakiness is the one root cause that causes teams to abandon CI/CD pipelines. So ephemeral environments are a necessity for making tests idempotent. And these test containers are very suitable, and they make it very easy to provision a fresh environment. So like instead of wasting time in spawning new virtual machines, you should bring back your whole CI/CD in front container-based solutions, because the step to spawn a new container is it's very easy. It doesn't take a lot of time. So like instead of spending a lot of time in cleaning the previous VMs, it's always better to create a new container. And in fact, most of the offering these days that you will find in the market are the container first. They already run on the containers.
In case you have any questions or you require any further information, you can chat with the team, or you can also drop us an email at support@lambdatest.com. We're here to help, and we'd love to hear from you.
Subscribe to our channel to stay on top of exciting features on your way. Happy testing!